So this is what I worked on last presentation. So if you were here last time, you saw this already. Using object detection to track the barbell, a very straightforward computer vision problem. But with that, then you get these displacement curves, and then you get velocity, purely just from this. So you can already go really far with just object detection for barbell. Again, very straightforward. You get the rep count, average rep, fastest, slowest. OK, so I posted that on LinkedIn, right? It went viral. It got 250K impressions. Yeah, and 4,000 likes. I probably gained like 1,000 followers. So the moral of the story is demo at AI Tinkers and post it on LinkedIn. That's the moral of this story, OK? OK, so you saw that. It's just, red box tracking. Really straightforward. But this time we're more ambitious, OK? We're trying to do something more crazy. This is relatively straightforward of computer vision. This one I'm really happy about, because this demo, I haven't really seen people do something quite like this. So before that, 2 off-the-shelf technologies that you can use, free to use. I did not train them. Like off-the-shelf, you can just use them. So one from Google and one from RoboFlow. So this type of pose landmarker detection is really common in these types of fitness tracking applications. So they're designed to be very quick inference on your phone or whatever, very lightweight, and it'll get you something like this. So you can imagine why I want to use this information to filter out some things or have some frame of reference for the deadlift, right? And then I'm also using a brand new model from RoboFlow, open source, a very, very permissive license. Like, you can use it in your production code. Sorry, get their video to load. Maybe not, but you saw it. It's like just a state-of-the-art segmentation model, using it off the shelf just to predict the person class, right? So it took some experimentation to find the right model, but this is a good one. I can vouch for it. OK, so remember we had these ingredients, right? So we had the bounding box for the barbell, this white line. Sorry, I can't really zoom in super well, but now I'm only looking at from the shoulder to the hip to the knee, so kind of creating like this greater than sign. That's this white line. Then I segment the person, again, just calling the model to segment the person, and then this is what we can create. So if you can see it, getting that red line from the edge of the back, because us as humans, we see in the video, it's like, oh, the back edge is very clear. So using all of that information to fit a red line on that back, and then we can do some fun stuff. So sorry, let me restart. So now we isolate that red line, right? Because, oh, I'm sorry, I totally forgot to mention this part. A lot of the feedback, again, when you post on LinkedIn, people just give you free feedback. And then you guys last time gave me free feedback. So a lot of it was about posture correction or posture tracking. Yeah. So I'm like, OK, I'm going to go do that. And us as humans, when we see someone execute the exercise, we're like, oh, the back is flat, the back is curved. Like, it's a very straightforward evaluation, right? So, OK, now we can do that. So I'll start with a third column, this average back shape. That's just rendering the average shape of that line during the concentric, we call it, is when you go up, right? So then, now, I purposely arched my back as hard as I could. Yeah. This is a difficult data set to collect. But purposely arching as much as I could. And what I wanted to output was, is it a good rep, a straight back rep, or is it a bad rep? And I was so pleased to see that it actually did it. You compute the roundness, and if it exceeds some threshold, then it's a bad rep. So yeah, definitely a hard data set to collect to get myself to like round my back as much as I can to do that. But, and I never explained the second one, which is then you can see like how rounded that it is, I guess, if that makes sense. It's like an activation of how rounded that the back is. So I proved it for the negative case, and then this video is just going to show that for all of my good reps, that it passed the test. So yeah, I'm excited because I haven't seen anything quite like this. And when I say I haven't seen anything, when I asked ChatGPT, Claude, and Gemini to look through the literature, I haven't seen anything quite like this yet. So yeah. So again, it's important to show that it works for the positive case as well. And sorry, did that make sense of this is showing the kind of the activation or like the roundness of it? And then you saw in the previous example that it was very clear that it was rounded. Yeah, that's it.